Welcome to the Unit 6, Section 2 video on laws of exponents. A power can be expanded by multiplying the base by itself, the number of times indicated by the exponent. Conversely, a number or variable multiplied by itself can be collected into an exponent. So, for example, here we've got 5 multiplied on itself 4 times, so we have 5 to the 4th. X is multiplied on itself 3 times, so we have x to the 3rd. And y is multiplied by itself twice, so we have y squared. So let's write the following using exponents. Here, 4 is multiplied on itself 5 times, so we have 4 to the 5th. Here, x is multiplied on itself 4 times, so we have x to the 4th. Now let's write the following without using exponents. So we start with 5 to the 3rd, x squared, y to the 4th. So you just expand it by multiplying 5 3 times, x 2 times, and y 4 times. Now in B here, we have negative 4 squared x to the 4th y. Be careful when you have a negative on something that is being taken to a power. Here, we do not have a parentheses around negative 4. So this is not going to be negative 4 times negative 4. The square is only acting on the 4, not the negative 4, because we do not have parentheses around all of negative 4. If we had parentheses around it and then it was taken to the second power, then we would have negative 4 times negative 4. But in this case, we'll have negative 4 times 4, and then we multiply x on itself 4 times, and then multiply y on the end. Now let's talk about the product rule. Recall that an expression of the form x to the n is a power. The base is x and the exponent is n. We're going to use this table, which indicates what to the first, to the second, to the third power, and so on, what each of these values is. You can do this in your calculator, but I put it here for reference. Let's look at 3 multiplication problems and write all 3 of these as a power of 2. So we have 4, which is 2 to the 2nd, 16, which is 2 to the 4th, and 64, which is 2 to the 6th. So I just substituted what each of those 3 numbers is with what power of 2 it's equivalent to. And I'm going to do that for these other 2 multiplication problems as well. Now that we have this set up, let's see if we can notice any patterns in the exponents. So we have 2, 4, and then 6 on the other side of the equals. Well, just looking at that, I know that 2 plus 4 equals 6. Let's see if that pattern holds true for the other 2. I have 3 plus 4 equals 7, and 3 plus 5 equals 8. So all of those are true statements, so you can multiply powers that have the same base by adding the exponents. And that gives us the product rule. For any number a and all integers m and n, a to the m times a to the n is equal to a to the m plus n. So if you're multiplying things with the same base, then you're going to add the exponents. So let's simplify each expression. 2n times 3n. Well, we're going to group our constants together, and we're going to group our variables together. And we can do this because in multiplication, it doesn't matter what order you multiply in. So 2 times 3 gives us 6. We're going to use the product rule on the n times n, because that's n to the first times n to the first. The same base allows us to add the exponents, 1 plus 1, which gives us 6n squared. For 4x squared times 2x to the third, we can group our coefficients, group our variables. 4 times 2 gives us 8. Use the product rule to add the exponents on your x terms, and that gives us 8x to the 5th. For C, we're going to group our coefficients, group our x terms, and group our y terms. 2 times 2 is 4. Use the product rule to add the exponents on your x and y terms. And that gives us 4x to the 4th, y to the 7th. For D, we have 2a squared b squared times a times 2a to the 3rd b to the 4th. Group our coefficients, group our a terms, group our b terms. 2 times 2 is 4. Add the exponents on our a terms, add the exponents on our b terms, and that gives us 4a to the 6th, b to the 6th. Now let's do an investigation on the quotient rule. Here are some powers of 3, and here are 3 division problems. Let's substitute in for each of these values a power of 3 based on what is in the table. Now let's see if we can find a pattern in the exponents. So for the first one, we have a 4 and a 3, and then on the other side a 1. So we know that 4 minus 3 does equal 1. That's a true statement. Let's see if that subtraction holds for the other two. We have 3 minus 1 equals 2. That checks out. And then we have 5 minus 2 equals 3. That is also true. So you can divide powers that have the same base by subtracting the exponents. That is our quotient rule. For all integers m and n and any non-zero number a to the m divided by a to the n is equal to a to the m minus n. So let's simplify b to the 5th over b squared. We'll start with the quotient rule. We subtract our powers, since we have a common base, and 5 minus 2 gives us 3, so we get b to the 3rd. Let's also look at this by expanding our terms. B to the 5th is the same as multiplying b by itself 5 times. B squared is the same as b times b. If we cancel 2 b's on the top and 2 b's on the bottom, we're left with b times b times b, which is b to the 3rd. Now let's take a look at a little bit more complicated example. So for this one, we are going to separate our a terms from our b terms, and then we're going to apply the quotient rule to our a terms and then to our b terms, and that gives us a to the 3rd b. Now let's take a look at power of a power. Let's take a look at 5 squared to the 4th. We can rewrite 5 squared to the 4th as 5 squared times 5 squared times 5 squared times 5 squared. Because remember, a power is multiplying something on itself 4 times in this case. Now we can use the product rule. Since all of these have a base of 5, we can add our exponents. And when we add 2 plus 2 plus 2 plus 2, we get 5 to the 8th. Let's do this for x to the 6th squared. We're going to multiply x to the 6th on itself 2 times, and then we'll use the product rule to simplify our exponents since we have the same base of x, and that gives us x to the 12th. Let's see if we can find a pattern in the exponents. Well, we know that 2 plus 4 is not 8, 2 minus 4 is not 8, but 2 times 4 is, so 2 times 4 equals 8. On the other one, 6 times 2 is 12. So we can find a power of a power by multiplying the exponents, and that is our power of a power rule. For any number a and all integers m and n, a to the m to the n is equal to a to the mn. We multiply our exponents. So let's simplify each expression. Here we have x to the 12th squared. So we're going to multiply the exponents, and that's going to give us x to the 24th. For b, we have x squared over 5 all to the 4th. That 4th power is going to act on the x squared and on the 5. So we have x to the 2 times 4, power to a power in the top, and then 5 to the 4th in the bottom, which when simplified gives us x to the 8th over 625. For c, we have 3x squared to the fourth. So 3 to the fourth, x to the 2 times 4. That is going to give us 81x to the 8th. And then for d, we have a to the third, b to the 6th, c squared, all to the 5th power. We have to do power to a power on all three items in the parentheses. And that's going to give us a to the 15th, b to the 30th, c to the 10th. Now let's take a look at zero exponent. There are two ways to simplify a to the third divided by a to the third where a is not 0, because we cannot divide by 0. So let's first start by expanding a to the third on both the top and the bottom. If we cancel out all of our a's on the top and all of our a's on the bottom, we get 1, which makes sense because anything divided by itself is 1. Now let's do this same problem by using the quotient rule, where we subtract our exponents. A to the 3 minus 3 gives us a to the 0. So since a to the third divided by a to the third equals 1, and it also equals a to the 0, we can conclude that a to the 0 equals 1. In general, any non-zero number raised to the 0 power is going to be equal to 1. And that is our zero exponent rule. So let's take a look at a couple of examples of this. To simplify negative 3xyz all to the 0 power, since everything in there is being taken to the 0 power and nothing in there is 0 itself, we can just say that this is equal to 1. It doesn't matter how complicated what we're taking to the 0 power is, as long as it's non-zero, it's going to be 1. This may be one of the easiest problems that you'll ever encounter. Now let's take a look at negative exponent. There are two ways to simplify k squared divided by k to the 7th, where k is not 0. So let's start off by expanding k on the top and k on the bottom. We have k multiplied on itself twice on the top and 7 times on the bottom. If we cancel out 2 k's on the top and the bottom, we're left with 1 over k times k times k times k times k, which is going to give us 1 over k to the 5th. Now let's look at it by using the quotient rule. K to the 2 minus 7 is going to give us k to the negative 5, which suggests that 1 over k to the 5th is the same as k to the negative 5. So that gives us the negative exponent definition. For any non-zero number a, any integer n, a to the negative n is going to be equal to 1 over a to the n. Now what the negative exponent rule is going to do for you is if you have a negative exponent in the numerator, you can move it down to the denominator and remove the negative from your exponent. Vice versa as well. If you have a negative exponent in the denominator, move it up to the numerator and remove your negative. Also, nothing will be considered simplified if you have negative exponents. So for something to be fully simplified, you have to take the negative exponents out by using this negative exponent rule. So let's simplify 12x to the negative 3. Since we have x to the negative 3 and it's in the numerator, we're going to move it to the denominator and remove our negative. So we have 12 over x to the third. For the next example, we have x to the negative 2 in the denominator. So we're going to simplify this by moving it to the numerator and removing our negative. So we end up with 4x squared. Now let's do a more complicated example that will require the use of several of the rules that we have learned in this section. So, to start this problem, it looks very complicated. Let's organize it by putting our coefficients together, our r terms together, our s terms together, and our t term in the last section of this. Negative 6 over 18 is going to simplify to negative 1/3. We're going to use the quotient rule on our r terms. We're going to use the quotient rule on our s terms. And we are going to use the negative exponent rule on our t term. So we'll pull that t to the negative 2 out of the denominator, bring it to the numerator as a positive exponent. Now let's finish off the quotient rules on our r and s terms by subtracting our exponents. And you'll notice that our s term ends up with a 0 because 5 minus 5 equals 0, and s to the 0 is our 0 exponent rule. We know that anything taken to the 0 power is going to be 1. And we don't have to write the 1, so the s to the 0 term essentially goes away. And we're left with r to the 10th t squared, which I'm going to move into the numerator. And we have 3 in the bottom, and of course the entire thing is negative. Thanks for checking out my video in the Algebra 1 Honor Series. You can subscribe to my channel. I've got the next video queued up for you, and if you need to check out any of the videos in the course, I've got the course playlist for you here as well. Thanks for watching.